Hello, I'm Simon Whistler. You're watching Top 10's Net, and in the video today we're following up on a previous video. We've got 10 more mind-bending theories about the universe.
Number 10. Why is dark matter so hard to detect? Throughout this list, we're going to talk about something called dark matter. Dark matter makes up about 27% of the universe and about 83% of all matter. It is invisible because light doesn't bounce off it, and it has a gravitational pull on regular matter, meaning it affects the movements of galaxies and galactic clusters. While it does have a gravitational effect, dark matter can pass through regular matter almost undetected. For all these reasons, dark matter hasn't yet been detected, but physicists are sure that it exists. One question is, why is it so hard to detect dark matter in Earth-based experiments? One possible answer comes from a group of particle physicists called Lattice Strong Dynamics Collaboration. In their simulation, they found that dark matter might have noticeable interactions with ordinary matter if they are both in conditions that are similar to the start of the universe, which is extremely high-temperature plasma. If their simulation is true, that means that in the early days of the universe, dark matter might have been observable. The good news is that these types of conditions can now be recreated at the Large Hadron Collider at CERN. Researchers are awaiting a chance to test the theory, and for the first time, dark matter could be detected. If their theory is correct, it would suggest that before the universe cooled, there was a type of balancing act between matter and dark matter before they spread across the universe. Number 9. Dark matter killed the dinosaurs. An asteroid is the most likely culprit for what killed the dinosaurs. However, what really kicked off the extinction 66 million years ago is still debated. A very far-out and cosmic theory comes from physicist Lisa Randall, and that is that an impact event was caused by dark matter. The basis of this theory goes back to the 1980s, when paleontologists David Raup and Jack Sepkoski found evidence that every 26 million years since the Great Dying of the Permian Triassic, which happened about 252 million years ago, and 96% of life was wiped out, there has been a great mass extinction. Upon further research going back 500 million years, it appears that Earth suffered some type of cataclysmic event approximately every 30 million years, give or take a few million years. However, scientists have never really been sure why cataclysmic events would happen on a timetable like that. Randall's theory is that dark matter is involved. Dark matter is believed to be scattered throughout the universe, and it is used as the scaffolding on which galaxies, including our home, the Milky Way, are built. As our solar system rotates around the Milky Way, it floats, and at times it bobs like a cork in the water. And this bob happens about every 30 million years. When we say bob, our solar system may encounter a disk of dark matter. The disk would need to be 1/10 the thickness of the Milky Way's visible disk of stars and have a density of at least 1 solar mass per square light year. Matter and dark matter can pass through each other, but dark matter can affect regular matter through gravity. The result is that when some matter floating in space comes into contact with dark matter, it could send things flying through the universe, which could ultimately hit Earth. If Randall's theory is true, dark matter could be responsible for major parts of the formation of the universe. Number 8. Life spread across the universe like an epidemic. When talking about the universe, there's one question that always pops up. Is there intelligent life out there other than our own, or are we just alone? Well, scientists wonder about this too, and currently are looking at how life, including our own, came into existence. According to a research paper from the Harvard-Smithsonian Center for Astrophysics, the most logical answer is that life spread from star to star like an epidemic. The concept that life spread from planet to planet and star to star is called panspermia, and of course, if you've seen Prometheus, that concept is a major plot point. If life passed from star to star, that means the Milky Way could be full of pockets of life. If that theory is correct, then it is possible that other planets in the Milky Way may host life as well. Another interesting thing they found in their calculations is that life could be spread by microscopic organisms that hitched a ride on an asteroid, or it could even have been spread by intelligent beings. Number 7. Why is the universe made of matter? Matter is everything that makes up space and has weight, and the opposite of matter is called antimatter. When matter and antimatter touch, they annihilate each other, which is exactly what happened at the start of the universe and helped to drive its expansion. At the beginning of the universe, there should have been an equal amount of matter and antimatter. However, if there was an equal amount of both matter and antimatter, they would have cancelled each other out and the universe would have ceased to exist. This has led physicists to believe that there was slightly more matter than antimatter. An amount as small as an extra particle of matter for every 10 billion antimatter particles would have been enough for matter to spread out across the universe. The problem was that while physicists knew there was more matter, they didn't know why. That was until 2008, when researchers at the University of Chicago were observing subatomic particles that lived very short lives called B mesons. The researchers, who won the Nobel Prize in Physics for their discovery, found that B mesons and anti-B mesons decay differently from one another. This means that it is possible that after the annihilations at the start of the universe, the B mesons and anti-B mesons decayed differently, leaving enough matter behind to create all the stars, planets, and even you and everything you touch, including the air you breathe. Number 6. Disorder made life possible. Entropy essentially means the amount of disorder in a system. If something is high in entropy, that means there is more disorder, and low entropy means there is more organization. A good example to visualize this is Legos. A Lego house would have low entropy, and a box of random disconnected pieces would have high entropy. What's interesting is that entropy may be the reason that life exists in the first place, which doesn't make a whole lot of sense if you take a look at the complexity of something like the human brain, which is the pinnacle of order. Nevertheless, according to a theory by assistant MIT professor Jeremy England, higher entropy may be responsible for life in the universe. England says that under ideal conditions, a random group of molecules can self-organize themselves to efficiently use more energy in their environment. How entropy plays into this is when energy is added to a system. The molecules jump and bounce off each other. If a few were to clump together and energy was used more efficiently, it would continue to hold together, collecting more molecules until eventually enough molecules clump together to become a life form. However, if there wasn't a high entropy state, the molecules would never have been bouncing off each other. Therefore, they would never have clumped together and brought about life. This theory has a lot of testing to go through. However, if England is correct, then an expert suggested that his name would be remembered in the same way we remember Charles Darwin. Number 5. The universe has no beginning. The prevailing theory of the start of our universe is that over 13.8 billion years ago, from a point of singularity, the Big Bang gave birth to the universe, and it has been expanding ever since. The Big Bang was first theorized in 1927, and the model is based on Albert Einstein's theory of general relativity. The problem is that there are some holes in Einstein's theory, mainly that the laws of physics break before reaching singularity. Another big problem is that the other dominant theory in physics, quantum mechanics, doesn't reconcile with general relativity. Also, neither relativity nor quantum mechanics explain or account for dark matter. This means that although the Big Bang is one of the best theories about how the universe started, it may not be correct. An alternative theory is that the universe was never at the point of singularity, and there was no Big Bang. Instead, the universe is infinite and doesn't have a beginning or an end. The researchers arrived at this theory by applying quantum correction terms to Einstein's theory of general relativity using an older model of interpreting quantum mechanics called Bohmian mechanics. And no, I'm not exactly sure what that means, but, good for them. Their method of testing the theory will also help account for dark matter. If their theory is correct that the universe is infinite, that would mean that the universe has pockets of a superfluid filled with theoretical particles like gravitons and axioms. If the superfluid matches the distribution of dark matter, then it's possible that the universe is infinite. Number 4. The universe should never have existed. Science fiction writer Ray Bradbury once wrote, "We are an impossibility in an impossible universe." And a model based on the Higgs boson particle from King's College London suggests he couldn't have been more right, because, well, the universe shouldn't exist. The problem is that 10 to the power of minus 36 seconds after the Big Bang to somewhere between 10 to the power of minus 33 seconds and 10 to the power of minus 32 seconds, the universe underwent something called cosmic inflation, which was a rapid expansion of the universe. If that is true, the inflation would have caused quantum fluctuations or jolts in the energy field. These jolts would have been so strong that they would have pushed the universe out of the Higgs field, which is responsible for giving particles its mass, and the universe would cease to exist. Of course, since you're watching this video, you know that this model isn't correct. So why does the universe exist when it really shouldn't? One possibility is that the findings are wrong. Another is that there may be some new physics or particles that have yet to be discovered. However, until we figure it out, we should just feel lucky to be here, when we theoretically shouldn't exist. Number 3. The universe started off one-dimensional. A commonly held belief about the universe is that the Big Bang was an exploding sphere, but another theory posits that for the first 1,000 trillionth of a second of the Big Bang, it was actually a one-dimensional line. Energy would race back and forth before creating a fabric, which is the second dimension. It then morphed into 3 dimensions, which is the world we see. If the model is correct, it would help address a few problems with the standard model of particle physics, such as the incompatibility between quantum mechanics and general relativity and cosmic inflation. However, if this theory is true, it would only lead to more mysteries, like what mechanisms were used to make the universe morph into the different dimensions. Number 2. How many dimensions are there? In the last entry, we talked about how the universe may have evolved into 3 dimensions. However, there are more dimensions than that. According to superstring theory, there are at least 10. Here's how it works. The first dimension is just a single line. The second dimension is height. The third is depth. And the fourth is duration. Where it starts to get a little bit weird is dimension 5. This is where the multiverse theory comes into play. In the 5th dimension, there is a universe that is very much like our own, and we would be able to measure similarities and differences. The 6th dimension is a plane where there are parallel universes, all with the same starting conditions. So, if our universe started with the Big Bang, so did theirs. The 7th dimension is a plane full of worlds with different starting conditions. Now, if all of this wasn't confusing enough, the 8th dimension is where things start to get really complicated and humans are having problems understanding it. Basically, the 8th dimension is all possible worlds, all with different starting conditions, and they all branch out infinitely. Of course, things get only more brain-melting from there. In the 9th dimension, there are all possible universes that start with different initial conditions, and the laws of physics of these universes can be completely different. In the 10th and final dimension, anything is possible, and that is just something humans cannot even fathom. Number 1. We're living in the distant past of a parallel universe. The term time's arrow was first introduced in 1927, and it aptly describes the flow of time. Humans perceive it as always going forward, and it also obeys the second law of thermodynamics, so entropy always increases. Eggs are cracked and scrambled, and they are never unscrambled and reform inside the shell. The problem is that if time only goes forward, many of the best equations about how the universe works, like James Clerk Maxwell's theory of electrodynamics, Isaac Newton's laws of universal gravitation, Einstein's special and general relativity, or quantum mechanics, would be incorrect. However, if time ran forwards and backwards, they would all work perfectly. One way that this is possible is at the Big Bang, 2 parallel universes were started, one where time moves forward and a parallel one where time flows backwards. The reasoning is that if entropy increases in our universe, then when the universe started, it would have begun in a low entropy and highly ordered state. That could be the end of another universe. That universe would start at the end and time would flow backwards while ours flowed forward. If we could see the other universe, we'd see time going backwards, and we would probably see into the future of our universe, and we'd be living in the parallel universe's distant past. That is, of course, if we're not the reality that is living in reverse and simply don't realize it.
So I really hope you found those theories interesting. If you did, please do hit that thumbs up button below, and don't forget to subscribe if you haven't already. Also, over there on the right, if you enjoyed this video, there's some other videos from us that you might enjoy as well, so be sure to check those out, and thank you for watching.